I'm going to go ahead and get started. I have a half hour. My name's Steve Wignall, and I'm from the University of Nebraska. I work in the nanotechnology department there. I do a lot of their outreach and other things at the university. So, what I'm going to be doing today is I'm going to give you a little bit of an understanding about nanotechnology, and also we'll do a little activity at the end to kind of simulate nanobots and how they work, and you'll get some other information about those also. So I'm going to go ahead and share my screen. Now, if you can't hear me, or if you want to have some input, I'll have questions at the end, but if something's not working right, type something in the chat and I'll try and fix that. This is my first time using this program for conferencing like this. I usually use Zoom, so let's hope everything works. So go ahead and share my screen and we'll get to the PowerPoint. That looks really nice. Come on. There we go. Okay, let's. All right, so what we're going to be doing today is robotics and nanotechnology. This is part of the NCMN. We're also part of the NNCI. Our facility is a Nebraska nanoscale facility, and I'm Steve Wignall. I already told you that, and I also work with Therese Janovic, who, if you have questions, her email and mine will be provided at the end, and you can get a hold of us. This is our building in Lincoln. We're attached to the physics building there, and we're on the end. Underneath and on the second floor is a lot of the equipment we use in nanotechnology. We have a clean room on the bottom room there, where we work in extremely clean environments where there's hardly any particles in the air, because the things we're working with are so small that dust or other types of particles in the air could ruin what we're using or working with or trying to make. So we want to keep the environment very clean. We have to wear suits to go in there also, and just very, very clean environment. And then we also have some other labs up on the second floor and down the basement, where we have like electron microscopes of different varieties that allow us to see the particles we're working with. If you want to know more about that, there is that link over on the right hand side towards the bottom. If you go to that, you can see some of the videos of our equipment and our research facility. Okay, I'm going to start with a little video about nanotechnology and robotics. The person they're interviewing in this is Dr. Claes. He is the head of the physics department, and he did this video clip a while back. So
Hey, Steve, we can't hear anything.
Oh, okay. Um, was there was there anything when I shared my screen that it would share the sound too?
It should have shared both.
I think I did that. Um, okay. Let me. All right. Let me. Can you can hear me though, can't
I
you?
can hear you perfect, yes.
You can hear me as
Yes.
far as I guess we'll just have to go on to the next slide because if you can, hopefully you can see my screen and hear me. I don't know why it didn't. In Zoom, I would have clicked a button to share the audio, but I'm not sure if that is part of this or not. So I haven't used this. Let's see. Let me get back to. Okay. So let's talk a little. You saw the video. You kind of saw some examples of some different types of nanotechnology in that video as far as the nanobots. Here's a few more pictures of some of the things that we're trying to implement in the nanotechnology. So nanotechnology is the study of manipulating matter on an atomic or molecular scale. So like I said, we're working with things that are super small and you can't see them with the naked eye. You'd have to use like an electron microscope or something in order to detect that they're there. And there's some pictures here of some different comparisons of size and how it would compare to nano. I think I have another picture in the next one. Okay, and then with robotics is a branch of technology that deals with the design, construction, operation of structural, manufacturing, applications for robots. The robots we're working with nano, we're basically taking atoms, realigning them, getting them to repeat different types of things so that we can get a movement. So if you look at that picture, like in the left-hand corner there, and then also in nature, there's a lot of things, we're trying to replicate like nature, like the flagella on the microbe there, for the movement. And then over in that other side, you see this little like submarine where they're using a chemical reaction that's producing uh, movement by different things reacting and causing gas bubbles to come out the back and be able to move it from one place to another. So we're trying a lot of different things to get movement and be able to facilitate different things to use in beneficial ways like medicine or um, all kinds of different things with the nano. Okay. Will they look like the picture up in the left? Probably not. They're going to be more things that are more chemical in structure, that we're putting together and then we get them to isolate like blood cells or white blood cells or tumors. Down in the bottom there's a picture of a little nanobot that this type of one, they make lots of them so they can basically use them to swarm or to do applications by having lots of them. And this just kind of shows how we might put together something in the blood that's very small. On the one end, it's got like a swimming tail, a small camera. You got the payload where maybe you're delivering chemicals to like cancer cells. And then you have a capacitor in there, which would be your energy source. The capacitor is like a battery, but it charges very quickly. And you could probably use the blood itself and a reaction in order to get that charging to take place. So it could keep recharging by just a reaction in the blood. And here's another example of what they're thinking it might look like if we put nanos into like a bloodstream and they go out and they would detect different pathogens, maybe by something on their outside structure that they would detect. Okay, and then the activity for today that I was talking about, since we've been talking a lot about this different movement, what we're going to do is we're going to take some common items and we're going to be dealing with like surface tension in water and the surfactants of soap. And so, if you collected these materials, this is what we would do. You would take a little bit of dishwashing soap, some paper, cut out a figure similar to down in the lower corner there, figure A, uh, some tap water. You know, it says you can put it in a large cake pan or a baking sheet. You'll need scissors to cut the shape out. And what we're going to do, you're going to put water in the pan. Don't fill it all the way to the top. Cut out your boat. It's going to be about an inch or two. The size, as long as it's not huge, you want it fairly small, but about an inch or two long and maybe an inch wide, cut kind of like what they show in figure A. Um, you're going to put it in the water and then you're going to put a little drop. You could use a toothpick or you could use like a Q-tip, put a little bit of soap on the end of it, put it on the boat, and see what happens as far as the reaction between the soap and the water. All right, I have another video. The sound does not, you don't need sound on this one. It's just going to show this activity so that we can go ahead and, if you don't do it, you can see how it's going to work. Okay, so I'll go ahead and this is only a couple minutes. All right, they're putting that on the water. So like I said, what's going on here is the soap, when you put it in the water, it's breaking the surface tension of the water. That's why the boat was floating on it to start with. And when you break that tension, it propels the boat. So the molecules and the surfactant in the soap are having a little reaction going on there. And that surface tension being broken is what propels the boat. You can also do this if you take a bunch of pepper, put it on top of a plate, put your finger in the soap, and you can see the separation due to the breaking of the surface tension. And if you don't want to use paper, you can get a leaf, do the same thing. Works nice. So some different ways to do the same thing. And this kind of simulates what's going on with the molecular motion we were talking about with the nanobots. Okay, so that kind of gets me towards the end of my presentation. I wanted to show you one more slide, and then if you have any questions, I wanted to keep about 5 or 10 minutes open to answer questions. So oops. So here are some resources if you want to know more about nanotechnology. You have up there the nano STEM resources. If you go to the NCMN website there, we have some kits that we have and some training videos that if people wanted those, they can see the type of kits we have. We charge about $50 per kit for some different types of hands-on activities, and most of them are very reusable, and you don't have to replace a whole lot of this stuff in them. We also have a virtual tour of our facility. on the online nanoscience clean room. There's some other sites that might be helpful if you want to get a few more things. You go to the Science on Demand. We have a virtual tour also. If you wanted to take your students inside of our facility and get a 10-15 minute tour of the different equipment in the clean room. On the right hand side, there are some different websites like NiceNet, a virtual microscope where you can go and kind of run the microscope virtually from your computer. They have things set up for it, but I mean, you're controlling it, but with the samples they have available. And then you got like NanoHub, some good videos on nanotechnology and other types of things, is making stuff put out by Nova. There's a magazine on nano called Nanews, and some other type things there with different videos and explanations. And down there at the bottom is Teresa's information. And if you want to get a hold of me, my email is swignall4@unl.edu. I'll type that in the chat if you're interested in that. So I'm going to go back to the main screen here, if I can do that. Okay. Okay, so I'm back on here. Sorry about the sound not working on the video. Hopefully you can hear me. I can see the chat stuff now too. I got Michael here who said, would putting a hydrophobic coating on specific spots create the same propulsion motion? Um, I would think you could do that. I mean, the surfactant should be able to on the soap. I would think could probably do something with that also. Um, I did another presentation where I talked about, the magic sand and how to make that. Magic sand and water. You've got the hydrophobic and hydrophilic deals going on there also. Um, so if you want to make your own magic sand, if you go to like Costco or Walmart and you buy the the coating or the spray cans where you coat like your furniture or your boots with this waterproof coating, you can do that with sand also. If you wanted to make your own sand, you have to do it several times. And if you're interested in knowing more about that, email me and I'll send you the instructions on how to make that also. That's kind of fun to do. And it's a lot cheaper than buying the sand because a can of the sealant only cost about $5, and you can make a lot of sand, silly or not the silly sand, the magic sand with that. So I'll put my email in the chat. Okay. All right. Do you have any other questions? You can type it in the chat and I can try and answer. Could you hear me the whole time except for the video? I'm sorry about the video not working. Okay, good. Yeah, I don't know why the video. If you want to see the video and it's on YouTube, I can send you that link also. I don't have it right on hand. I have not done any work with self-folding nanobots, but they have over in the engineering department. They have a robotics research group over there, and I got to visit their lab a couple times, and they're really doing some neat things. They're they're working with the self-folding type of thing. They also, are trying to work with making right now, the last time I saw what they'd made, they had something that was about that big that they could put inside the body and it could go and take samples at different parts. They use like pig carcasses to do that, but it does a rolling type motion, and I think they were also working on the folding type thing too. So there's just so many things we're learning and starting to apply. So, and like I said, I am more than happy to answer any of your questions. If any of you want to email me and know more about something, if we ever open back up, you can come over for a tour too, and we'll take you, or if you got classrooms and kids and you want to come in, and we can set up an activity for you also, because we really like to be able to share these things. So, all right. I might have left a little bit too much time for questions, but the video would have went a few more minutes. That would have been about right with that. So, I mean, so if there are any other questions, okay. Well, I'll probably go ahead and end it there. Like I said, if you have something you'd like up on my email, there should have been an at unl.edu instead of the dot there. Sorry. So it's swignall4 at unl.edu. All right. Well, thank you for attending today. Appreciate it. And if you got time, or if you're at home, try out that boat. And if you want more information on how to make the nano sand, I'll be more than happy to get that to you also. So you guys have a great day. It means a lot when you show up for things like this on a Saturday. Shows you have a real interest in things like this. So have a good one, and we'll talk to you later. Thank you.